All right, so we're going to actually take a look at our practice problems. I'm going to solve the last one. If you still have a few to solve, quietly do so. Otherwise, I would like you to sit quietly for a moment while everyone solves their practice problem. There we go. Okay, ready to rock. All right, let's look at these together. Okay, so we look at number 1. We had 2 and 1/6 times 4.5. So when we multiply those two together, I chose to use the improper fractions method. So that meant I converted both of the mixed numbers into improper fractions first. And you can see that here. 2 and 1/6, I would take 6 times 2 plus 1 to get 13, and I'd keep 6 as my denominator. Then for 4.5, 2 times 4 plus 1 gets me 9 for my numerator, and keep 2 as my denominator. So then I have 13/6 times 9 halves, or 9 over 2. That would get me 13 times 9 is 117. 6 times 2 is 12. Well, I need to convert this into a mixed number. So I would ask, how many times does my denominator 12 go into my numerator 117? Well, I did the math right here. So if I take 117 and divide it by 12, it ends up going in 9 times with 9 left over. So that would convert it into 9 and 9/12. So remember, the number on top becomes our whole number, 9. The number left over becomes our numerator, 9, and then we keep 12 as our denominator. Well, 9/12, I can divide both 9 and 12 by 3. So I can simplify it one more time. So 9 and 3/4 is my final answer here for number 1. How did we feel about number 1? How did we feel? Okay. How many of you was it a little tricky simplifying a little bit? Yeah? Okay. Yep. Simplifying can be the hard part. And that's why, if you don't like all of this dividing and simplifying, yep, partial products. There's usually less simplifying that goes into the partial products method versus the improper fractions method. But you have more, exactly. So the way you guys can think of it With the partial products method, you're doing more steps right away. True, so you're doing more steps right away with the partial products method, but with the improper fractions, you're doing more steps after you get the answer with the simplifying. So it's up to you whether you want to do more steps here or if you want to do more steps with simplifying. So again, you pick the method that works best for you. All right, so the number 2, 3/4 times 8.5. Well, since I had 3/4 already, I did not need to convert that into a fraction or an improper fraction. I only had one mixed number, so I had to convert that into an improper fraction. And so you can see that here. I kept the 3/4, and then I took 8 times 2 plus 1, which gets me 17, and I put it over 2. So 3/4 times 17/2, that gets me 51/4. Well, that's an improper fraction. So like Drew was saying, now we have to simplify. So this is where more of the work comes in for improper fractions. So I asked, how many times is 4 going to 51? Well, I did that work over here. 4 goes into 51 12 times with 3 left over. So my 12 becomes my whole number. The amount left over, 3, becomes my numerator, and I keep 4 as my denominator. I cannot simplify 3/4 anymore, so 12 and 3/4 is my answer. How did we feel in number 2? How do we feel in number 2? Okay, how do we feel in number 2? All right, awesome. Will, did you have a question?
How did you get 4 from 4 times 2?
Oh, you're right. That should actually be 8.
No.
Or did I do...
4 times 2 is 8. You simplified it to 4. Yeah. Yeah.
But I would have to simplify that. I think I accidentally did... I was thinking 2 times 2 here instead of 4 times 2. So technically, it would be 8. So then we would actually ask, how many times does 8 go into 51? How many times does 8 go into 51, 5th grade?
6 times.
6 times, exactly. So 6. Because if you think about it this way, 5 times 8 gets you 40, plus another 8 gets you 48. That gives us 3. So actually, our answer would be 6, because that's how many times it goes in, 6 and 3/8. All right. Thank you, Will, for seeing that. I apologize. Okay. Yep, 6 and 3/8. I'm sorry about that. All right. Yep, exactly. Exactly. Because, yeah, 3/8 and 3/4. Cool. Exactly. All right. Then we have number 3. So number 3, 2 mixed numbers. So, again, I converted them into improper fractions because I was using method 2. So, 8 times 4 is 32, plus 1 is 33. 5 times 2 is 10, plus 1 is 11. So I get 33 over 8 times 11 over 2. Yes, Drew? I haven't seen anything saying indoors, so far, yes. Yep. So when we take 33 over 8 times 11 over 2, we get 363 16ths. Focus. That's a big number. I need to figure out how many times 16 goes into 363. So I did that down here. 16 goes into 363 22 times with 11 left over. So 22 becomes our whole number. The amount left over, 11, becomes our numerator. And 16 becomes our denominator for 22 and 11 16ths. Yes, Will?
I had a majorly dumb mistake. I thought 42 minus 32 was an
Oh, that happens sometimes. That is okay. That's okay. And then we had number 4, and this one had a couple different steps because we had to first add and subtract before we could multiply. So what I did is I rewrote the problem to where they had common denominators. So 1/6 plus 2 2/3 becomes 1/6 plus 2 4/6, and then 1 1/4 minus 1/2 becomes 1 1/4 minus 2/4. So first I added, so 1/6 plus 2 4/6 gets me 2 5/6. And then for 1 1/4 minus 2/4, I can't subtract 2/4 from 1/4. So I borrowed from the whole number 1. My numerator became a 5. So then I could take 5/4 minus 2/4, and that got me 3/4. So then I had 2 5/6 times 3/4. So I converted my mixed number into an improper fraction here. So 6 times 2 is 12, plus 5 gets me 17. So 17/6 times 3/4. That got me 51/24. I asked how many times does 24 go into 51? Did that math over here. It goes in 2 times with 3 left over. So 2 3/4, or 3/24. However, 3 can go into both 3 and 24. So it would be 2 1/8. Overall, how did you feel about these practice problems? Show me, 1 through 5, okay? If you're at a lower number, do you think maybe doing I think everyone liked the improper fractions method. Do you think maybe doing the partial products method might work a little bit better? Yeah, okay. So I challenge you, if you had a hard time doing the improper fractions method with our practice problems, I encourage you to use the partial products method on your homework. It's more steps at the beginning, but then you usually have less simplifying to do at the end. Okay, homework tonight is page 497. I did not ask for you to start talking, Will. So we are on page 497. You are circling number 1, number 3, number 5, number 8, number 11, number 14, and number 17. So again, we are on page 497. We are circling number 1, number 3, number 5, number 8, number 11, number 14, and number 17. You have a couple minutes to work on this before PE. I will turn on work music.